And if you find my network slower, you just inform me. I've connected it with the college Wi-Fi. So if you are facing trouble in getting the data flow, I change it to the mobile network. Okay. So last session we discussed we started with the data flow unit, right? With a single bus organization, okay, where we will have a different set of registers, set of general purpose registers named from R0 to Rn-1, and temporary registers. There will be few temporary registers here for indication, indicated only one, and then one register, Z register, to store the result, and Y to give either one of the input, or in case of incrementing program counter to give a constant value 4, considering that it's byte addressable and each word is a 32-bit word. Okay, and instruction register to store the instruction, MDR to give the data, where we load the data in MDR during the write operation and we take the data from MDR during the read operation. Okay, and MAR only one single direction register, right, where always the address will be given, right? So it's only unidirection, right? To whenever we want to access the memory, we give the address through the memory address register, and then the program counter to specify the location every time from where the next instruction for execution should be taken. Okay, and I also told you that each of these registers will be having the control signal for in as well as out, to latch, to write the data into the register, right, to latch the input whatever it is getting into the register. Same way, whatever is already stored, to take that value and process it, right, depends on the instruction. So each of these registers will be having at least 2 control signals, right, except Y register, right, and the control signals are in and out. For example, in case of R0 register, there will be 2 control signals, one R0 in, right, and the another control signal is R0 out. Okay, same way every register will be having 2 control signals, right, except for Y register where there is no Y out, because I already explained that for loading the input you need the control signal, but to get the output not necessary, because the output will be chosen here by the select control to the max, which will decide whether a constant 4 should be given for the current arithmetic or logical operation, or Y input should be given as the input to the A. Okay, so because of that control, we are not adding additional control to the Y register. So Y register has only one control signal, that's Y in, and all other registers have 2 control signals, in and out. Okay, and in addition to that, MDR, the memory registers alone, have 2 more extra control signals. To in and out is to control the process on the processor side. Okay, and 2 more in and out control signals to control the process on the memory side. Okay, so additional 2 more signals will be added for memory registers which deals with the memory. Okay, so those also we'll discuss in detail. Now are you clear with the basic information? Srimati.
Ma'am.
Srivitsan.
For MAR also there will be 4, ma'am.
Yeah,
4
because
signal.
MAR will be dealing in both the direction. Okay, one, when you send the data from, for example, if we are loading, if we are trying to read some data from the memory, okay, I am giving that the content of R0, For example, I'm giving the instruction like MOV. I'm giving instruction like MOV R0 within bracket, and then I'm giving R1. Okay. When I give like this, if I'm giving without this square bracket, it's simply move the value of R0 to R1. Always here the notation followed in your textbook is what comes first is the source and what comes last is the destination. Okay. So according to this instruction, whatever is the data in, if I am giving simply move R0, R1, if I am giving instruction like this, move R0, R1, first is the source, second is the destination. So whatever is the value in R0, that will be moved to R1. Okay. But here I have given a square bracket. That means the content of R0 is only the address. It's not the data. Okay. That means the data, whatever is pointed out by R0, supposed to be copied, moved to R1. Okay. So in that case, what we will do? We will be giving in this case, the address we loaded in MAR, whatever is the data in R0, that loaded in MAR, and we give that it's a read operation, right? So in this case, there will be, once the data is ready, the data will be fed into, loaded into MDR, right? And then from MDR, it will be through the internal data bus, it will be given to R1 register, okay? If it is the other way around, for this itself we need two control signals, okay? One from the memory side and one in the processor side. If it is the other way around, where you are doing a write operation, okay, the instruction will be changing like move R1, R0. Or instead of braces over R0, if you find braces over R1, then it's a memory operation, which is a write memory operation. Okay. In that case, we load the data in MDR, right? And we load the address in MAR, and then we say that it's a store write operation. So in that case, once the memory location has been selected, the data which is being loaded in MDR supposed to be loaded to the selected memory location. So for one direction, it requires two control signal, and for transferring in another direction, it requires two more control signal. Okay. So for MDR, naturally, we will be requiring four control signals. We will be discussing it in detail. What is the name of the control signal, and when it should be enabled, and in what sequence it's supposed to be enabled. All that we'll be discussing in detail. Okay.
Why we have unidirectional arrow from bus to MAR? So
MAR, we always, the memory is not going to give any address. Whenever we want to access the memory, we only specify the address. Either the processor specifies, depends on, most based on the instruction, the processor finds out where the address is and it loads it. Okay. So in that case, only possible way is whenever we want to access the memory, the address has to be specified. Okay. That means the memory cannot specify any address here. So naturally, it's only one direction is required. Two directional control is not required. Because in no scenario, the memory is going to load some address into the memory address register. Its sole purpose of memory address register is to access the particular memory location with a read or write operation. So in that case, whether it is a read operation also, we only specify from which location it's to be read, or if it's a write operation also, we only specify in which location we want to store. So in both cases, the address needs to be specified. Okay. So there you need only one direction control.
okay.
Any more queries, guys? So taking your silence as no, we discuss the each of the operation whatever I have mentioned now. We discuss all this in, we are going to discuss it in detail. Okay. So the first thing in any instruction, first you have to fetch the instruction and then only you have to go with the execution, right? And these phases sometimes you can see that I think since you have learned ARM7 core, I assume that you have learned different stages of pipeline. Can anyone tell me how many stages of pipeline you have learned? Srimati?
Yes, ma'am.
What are all the stages of pipeline you have learned?
3-stage pipeline, I guess.
Any other stages or only 3 stages? Anybody? Any other stage learned or only 3 stage pipeline? I'm asking an information, I'm not questioning. So please somebody respond please.
5 stages, ma'am.
3 you learned, 5 you learned. Did you learn 7? Did you learn or not, please? Okay, assuming that at least 3 and 5 you have learned, right? In that itself, if you see it, execution phase and fetch phase, both phases sometimes will be having multiple stages, right? When you say execution phase, depends on whether it's 3 phase or 3 stage or 5 stage. You will have separate decode phase, separate read or collect the input, and then execution, and then store. Different stages will come up. Okay. So for any instruction, first we fetch the instruction and then we go into the execution phase of completing the instruction session, right? So in fetch phase, first thing what we do is the program counter only depend on to know what instruction to be executed. Okay, and for that the content of the program counter, right, gives some information. That information is not the information which is to be loaded in the instruction register, because you see 2 square brackets there. That means content of program counter again gives the address. For example, if content of program counter is X, okay, again the content of X only should be loaded in the instruction register. Okay, that is why there you see 2 square brackets. When we indicate 1 square bracket, it means the content of that register. Okay, when we have 2 square bracket, again the content of register pointing out something, and that content in that pointed out location only whatever is the data we are looking for. Okay, so every time we have to find out whether it is the there is no intelligence in the system design to identify whether it is the address or data. Okay, it is on the engineer who design it indicates that, or when you do the program also, it's the engineer who decides that the value in particular location or in the register to be used as a data or as the address. Okay, there is no way or intelligence in the system you design to differentiate and look into it and use the data. Okay, we only have to decide whether it should be whatever is the value there should be used as the content, or should be used as the data, or should be used as the address. Okay, here the content of program counter, assuming that some value X again is not the value should be loaded in the IR. The content of the data whatever is pointed out are stored in X only should be loaded in the data in IR. Okay, that's why we are having two square brackets there. So once we loaded the content in IR, then the decoding process starts to identify what operation it is, what arithmetic operation or logical operation or simply some copying or branching, and in case of arithmetic operation, what arithmetic operation it is, whether addition, subtraction, like increment or decrement. All these things will be decoded and identified by the instruction decoder. Okay. In the meantime, what we do is, since the instruction has been taken by whatever has been pointed out by the program counter should be incremented to point the next instruction. Otherwise, every time you fetch the instruction, you will be fetching the same location again and again. That means only one instruction is getting executed again and again. Okay. So we have to update the program counter value, and most of the case the updation is increment. Okay. And later it will be changed, depends on what instruction it is. If there is jump or something, you know, we'll be changing the program counter value later stage after realizing what is to be executed next based on the current instruction. Okay. And I already told you, we assume that it's a 32-bit word size of byte addressable memory. We increment the content, that is here it is the address. Okay. So we increment the content of the program counter by 4. Okay. So that it will be pointing the next 32-bit value, which will be the next instruction in the program. Okay. And once the instruction register value has been decoded and identified what operation it is, then it enters into the execution phase. Okay. So in fetch phase, we load the instruction pointed out by the program counter into the instruction register, and in the meantime it is getting decoded. We increment or update the value of the program counter to point to the next instruction, and then once the instruction has been decoded, we enter into the execution phase. Are you clear with this? Yes. Are you clear with this or not? Okay. So now depends on the instruction. It can be some arithmetic or logical instruction, or sometimes simply some moving data from one location to the another. And here we are mainly discussing the data flow unit. That means whatever the possible requirement of moving data from one place to the another, possible sources and destination, we have to provide the provision for moving in all possible directions. Okay. So we have listed out the possibilities. One will be either you read the value from the memory location and load it into one of the CPU registers. Okay, read the value from the memory and store it in one of the registers. This is one possible fetch or data flow required. Okay. Another data flow required is the opposite direction, right, where you have a memory unit and you have a register set. Okay. So one possible operation is moving some value from memory to the register, that is the read operation. Another possible movement is store some value from the memory, from the register to the memory. That is another possible data flow required. Okay. Apart from between the memory and the registers, there are other possibilities also, like you transfer the data within the registers. In the register set, you know that there are multiple registers. So within the register set also, you may be requiring some movement. For example, moving R1 value to R2, right? Like that within the CPU registers also, from one CPU register to another register also you may require. Or sometime you have to move it to the ALU also. For example, if I am giving instruction like add R1 comma R2. Okay, in that case the value of R1 as well as the value of R2 should be moved to ALU, okay, as input A and B. Only then the operation can be carried out. So in this case, from register the value should be moved to ALU. And at the end of the operation, once the arithmetic or logical operation has been performed, then the result should be moved into the CPU register. Okay, so here always when you represent only two registers, the last one comes the destination. So value in R1 and R2 gets added and the result gets stored in R2, right? So the possibilities are either between the memory and registers, or within the memory set itself you have to move, or from memory to the ALU, or from registers to ALU, or from ALU to the registers. Okay, so these are the possibilities where you have to provide the option for data flow. Okay, so here is the first case. If you want to read a word from the memory, what are all the sequence you have to do and what are the control signals you have to enable. This is what we should know, so that when we design the system we provide all those facilities and ensure that it functions as what expected. Okay, so here like I said, move the content of the location pointed out by R1 to the register R2. Okay, so you fetch a word from the memory which is pointed out by R1 and load it into the register R2. Okay, so in this case, during the execution phase, the first thing what we do is the address should be loaded into the memory address register. And then once you load the address, we have to specify whether we want to read it from the memory location or we want to write it into the memory location. So what operation it is, whether it is a read operation or a write operation. And once you have given the required informations and specified what operation it is, you have to wait till the operation gets completed, because your memory is a slow processing peripheral when compared with your processors. Okay, so naturally you have to wait till the operation gets completed. Only then you can carry on with the next step. Without you having the data, you cannot load something into the R2 register. So you have to wait till you get the data from the specified memory location. Once you receive the data, then you can move it into the destination. Only then the execution of that instruction gets over. Okay. So the first step what we do, into the MAR register, we load the content of R1. Whatever is there in R1, that is the address, and we load it into the MAR register. Once you have loaded, we also specify that it is the read operation, so that it knows which direction the data transfer is required, whether from memory to the registers or from registers to the memory. The direction of data transfer is specified by the read or write operation. Okay. So once we loaded the address, we also specified it's a read operation. The next step, we have to wait till we get the data. Okay. Till we get the data, there is no other operation can be carried out for this case. So what we do, once we loaded the address, we specify that it's a read operation. We wait for the memory function complete signal to be enabled. Okay. When we receive this signal memory function complete MFC from the memory, it indicates that the operation specified to the memory has been over and the data is available. So during read operation, the data will be available end of memory function complete. The data will be available in MDR. And in case of write operation also, we load the data through MDR only. Always the data should be loaded, should be shared only through MDR register. Okay. So during read operation, once memory function complete signal is active, that means that the data from the specified memory location has been loaded into the register MDR. So then what we can do? We can complete the execution by moving that value from MDR to R2 register. Okay, by enabling the MDR out control signal and enabling R2 in control signal, so that whatever has been out from MDR will be latched to R2. Okay. In the meantime, only operation you can carry out will be incrementing your program counter if not done earlier, right? Or any other operation which is not going to affect this flow, that can be carried out. Okay. So there is no fundamental or base clock here to control the entire process. If everything is time generated based on a single clock, then you know that it's a synchronous system. And if everything is based on the control signals enabled, which we call here as the handshake signals, then it's an asynchronous system. Okay. So if you are not depending, you are waiting for the control signal. For example, memory function complete, here is the control signal. So we wait till that gets activated. We are not triggering the next operation based on the clock. So that means it's an asynchronous transfer. Okay. And some cases, for effectiveness of the system design, part are some of the operations carried out based on the clock timing generated, and some of the operations carried out by the control signals are the acknowledgement signals, which is called as the handshake signals. So those systems are not completely an asynchronous system, are a synchronous system. And there are also designs like globally GAL system, which is globally asynchronous and locally synchronized. So different in VLSI, you can design different sophisticated systems based on for what you are giving the priority. It's always a trade-off in the design. So you have to prioritize what performance parameter you are giving the importance, and based on that you can have the remaining parameters you can adjust to achieve your prioritized parameter performance. Okay. Are you clear with this flow? Or you need a minute to digest it?
Ma'am, we are clear.
Okay. So the next operation is fetching a word from the memory, the other direction of data transfer. I mean, for the same, whatever we discussed now, what control signals you have to enable is what is here. Like I said, when for all other registers, there will be only two control signals in and out with the same name of the registers. But for MDR alone, there will be two additional control signals. Two signals for the processor side and two signals for the memory side. Okay. So signals on the processor side will always be in and out only. Control signals named as in and out only. Okay. So here you can see that MDR in, which enables gate to allow the data available through the processor bus to be latched into the MDR register. Okay. And same way MDR out signal, which enables this gate, right, to allow the available data in MDR to be sent through the processor bus to wherever the data is required. Okay. This is on the processor side. On the memory side, we have two more control signals where they are also named as in and out only, but indicated as MDR out E enable, right, to differentiate this out and this out. Same way to differentiate this in and the in on the processor side. Okay, here also it is indicated as E. So during read operation, this control signal will be first enabled, right? During read operation, this will be first enabled, and then once this is enabled, it gets latched to MDR register, and from here, this will be the next control signal which will be enabled. Okay, so the data from the selected memory location first gets loaded into MDR register, and from MDR it has been given to the through the processor bus, wherever is the destination, it will be loaded there. This is for the read operation, and the sequence cannot be changed. Without you enable the in, the data won't be loaded here. Okay, so first you have to latch it into the register by enabling MDR in E, and then only you have to enable the out, MDR out, so that you get the right data. Otherwise, if you enable MDR out first, whatever is there already existing in MDR, that only you will be getting, you won't be getting the data what you are looking for. Okay. And for write operation, we have to specify what data to be written in the selected memory location. So first we enable MDR in, we enable first, where the data gets latched into the MDR register, and from here it will be given to the memory through the control signal MDR out E. So this has to be enabled next for write operation. Okay, so one direction data flow achieved this way, right, and another direction of data flow I have indicated with different this I have written with curved lines so that you understand that two different direction of data transfer takes place. Okay, so the 1 and 2 alphabets are for indicating the read operation control signals and in what sequence. The Roman letters 1 and 2 are for write operation control signals and in what sequence. Clear this?
Yes, ma'am.
Okay. So here the same thing whatever we have discussed has been given in a timing diagram, where first the control signal has been activated and the address will be placed in the memory address register. Are you guys able to hear me?
Yes.
Yes, ma'am.
Okay, I am getting a notification of bad network. And then we say what operation it is, read or write. So accordingly, memory read or memory write control signal gets activated to the memory. Okay, and then we enable memory data register enable. Okay, then once the data has been placed on the data bus or in MDR register, then the memory function complete gets activated. Only after memory function gets activated, it indicates that the data is available in MDR register. Okay, then we enable MDR out. So we take the MDR once MDR out we activate, whatever is the data there, it gets loaded into R2. Okay, the same process whatever we have discussed here given when it should be activated, the timing should be maintained. Otherwise we may not be able to attain whatever the result we are looking for. Okay. So just take a minute to understand the timing diagram, right? How, when, at what timing, what control needs to be enabled. Once you understand the time, or you have some doubt in the timing diagram, you let me know. Clear, or you have any doubt?
No doubt.
Okay. So this is in one direction, right? But the next operation we need is to transfer the data in another direction. That's the write operation. Okay. Where for write operation, we have to specify what location. Also, we have to specify what data to be written there. Okay. So it's move R2, comma R1, which is the memory location because given with the square bracket. Okay. So the data in R2 should be copied to the location pointed out by R1. That means R1 is giving the address here. So value of R1 should be moved to MAR, and the data is given by R2 here. So value of R2 should be moved to MDR, and then we have to specify it as a write operation. So once we specify these three details, that is what, which location, what data, and what operation. Once we have specified these, then we have to wait till that memory function gets completed. Okay, so once we load the address, which is the destination, is available in R1 and source data is available in R2. So we load MAR with R1 content and we load MDR with R2 content and enable write. Then we wait for memory function complete signal to be activated. Okay, and if you have the facility of multiple bus, in that case you can do 1 and 2 together, right? But if you are having a single bus, then you have to wait till moving R1 value through the data bus to load it to MAR. Then you have the content of R2 through the data bus or the processor bus to load the data in MDI. But if we have multiple bus, parallelly we can load the memory address register, data register, and then carry on in one step itself the operation. Okay, so depends on the architecture also, the sequence and at what time each of the control signal gets activated will be differing. Okay, and wait, once we get MFC, that means that the operation is over and the data has been loaded in the specified memory location. Okay, clear?
Yes, ma'am.
Okay. So this is for your you knowing that how the control signals in case of registers. So any R general purpose registers, that's why it is indicated as I. Okay. R, if it is 0, it will be R0 in. If it is 1, R1 in. If it is R2, it will be R2 in. Okay. Same way, Ri out will be for getting the whatever is stored in the register to get that value out to load it in another register. And Y register alone having Y in, and I told you Y not is Y out is not required. Okay, and Z also has Z in and Z out control signals. Okay, so if you want to move some value between two registers, then what do? You first, for example, if it is between R1 and R2, okay, where R1 is the source and R2 is the destination. What are all the control signals we have to enable in this case? Can anyone tell me? If the instruction is move R1, R2, what are all the control signals needs to be enabled? And which one you enable first? Anyone tell me? Adarsh. Adarsh Singh.
Yes, ma'am.
Roll number. Yeah. Tell me what control signal needs to be enabled and which one first and which one next.
Ma'am, 1.
Repeat, please. I didn't hear you clearly. Yes, Adarsh. What control signal needs to be enabled first and what next for this instruction to move data within two registers? Anybody else?
Ma'am, is it R in?
Yeah, which all registers having in and out signals. So which RN should be enabled here? And I repeat, the first one is the source and second one is the destination. So now tell me which R in should be enabled and which R out should be enabled. Anybody else?
R1 in. Mm,
Yes, I think Srivatsan is answering. Am
yes,
I right?
ma'am. Yes, ma'am.
Okay, R1 in should be activated first so that the output of R1 gets latched to the processor bus. Okay, and then you enable R2 out so that the data whatever has been latched to the processor bus gets connected. So R1 out should be enabled first. Okay, sorry. R1 out should be enabled first because that's the source from where you are going to take the data. Okay, and then this data in R1 should be returned into R2. So R2 in should be enabled next. Okay,
Ma'am,
so when you, yeah,
first we'll take content of R1 and then we'll send it to MDR, no?
that is only if
And
you want to read it from the memory. If the instruction is this having a square bracket, then it
so,
means content is R1 is giving the address and you have to go to that location and take the data. This is between the registers, right? So R1 is having some value which is to be moved, copied to R2. Okay, so R1,
so we are directly latching both the registers.
yeah, R1 out we enable so that one of the gate of output gate gets open and another input gate is open. So directly latching the output of, for example, if this is R1, I am opening the in gate, and in other place R2 output gate I open, right? Out gate I open. So it is like through the processor bus, output of R2 gets connected with the input of R1 and latched into R1. So it gets stored. Okay, so R1 out should be enabled, then you enable R2 in. It's between two registers directly if you can latch it. Okay. So this is for simply transferring the data, and we discussed 4 to 5 cases of possible transfers, and for 3 cases we discussed what control signal and what sequence needs to be enabled, and in the next class we see the remaining flow. Okay, you have any doubt in this, you can get it clarified now. Aditya AS, either mute yourself or you have some doubt, you speak up. Aditya AS, do you have anything
No, ma'am.
to discuss? Okay. And if you people want me to go to any particular slide also, you please let me know.